heat transfer through the composite materials, and we do some problem already. So today we do this problem on composite cylinder and sphere. So this is the problem. A steel pipe with 50 mm outer diameter is covered with a 6.4 mm asbestos insulation. K given, followed by a 25 mm layer of fiberglass insulation. The pipe wall temperature 393 Kelvin and outside insulation temperature 311 Kelvin. Calculate the interface temperature between the asbestos and fiberglass. So basically, suppose this is your steel pipe. Okay. So this is 50 mm outer diameter and covered with a 6.4 mm asbestos insulation. So first, this is 6.4 mm thickness asbestos insulation. Then 25 mm fiberglass insulation. So this is 25 mm fiberglass insulation. Okay.
OD.
Outer diameter. OD means outer diameter. ID OD হচ্ছে outer diameter. সংক্ষেপে লেখা থাকে। ঠিক আছে, এটা মাথায় রাখবে। প্রত্যেক বলেছি যদি কোনো প্রবলেমে OD লেখা থাকে means outer diameter আর ID means inner diameter. Okay. So this is the you have to find out this interface temperature. So here temperature given, this is 393, means at this point 393 Kelvin, and here you have to, and at the outer surface temperature 311 Kelvin. So if we consider this is T1, this is T2, and this is T3. So T1 and T3 given, you have to find out the T2. So now we know Q equals to ki jani for a cylindrical surface. This is T1 minus T2 divided by কি হবে ln, ধরো এটা হচ্ছে R1 then R2 then R3. Okay, so ln R2 by R1 divided by twice pi into K into L. তাহলে এটা হলো T1 to T2, similarly T2 to T3 we get it same Q, T2 minus T3 divided by ln R3 by R2 divided by twice, এখানে ধরে নিই A ধরি, তাহলে ওখানে KB twice by KB into L equals to Q, কি হবে T1 minus T3 divided by summation of total resistance. So in this way we can find out the T2. So this is the drawing. Here you see this is the R1 and this thickness 1 to 2, this thickness will be 6.4 mm. It is given 6.4 mm asbestos sheet. So R2 equals to R1 plus 6.4 and 2 to 3 is 25 mm. So R3 equals to R2 plus 25 mm. Okay. So from this we get R1, R2 and R3. And K is given. K1 is given 0.0485 and Ka asbestos ke A দেওয়া হয়েছে, fiberglass ke B দেওয়া হয়েছে। তাহলে Kb equals to given fiberglass 0.0485 and A will be 0.165. এক মিনিট দাও, একটা ভুল আছে, বুঝতে পারলেন? এখানে asbestos শিখতে হবে এটা, পরে আমি ঠিক করে দেব এটা, আর এই fiberglass সেকশনটা হবে এটা। ওকে, so now your R1 equals to diameter given, so this is the 50 by 2 25 mm. R2 equals to R1 plus 6.4 mm asbestos, so this is the 25 plus 6.4 and R3 equals to R2 plus 25. T1 given, T3 given, K, KB given. Now we apply this expression. So Q equals to, দেখো আমরা এখানে দুটো সামেশন করে দিয়েছি, twice pi L Q1 minus T3, এখান থেকে Q টা ফার্স্ট ফাইন্ড আউট করব। তো R2 R1 K A, R3 R2 B KB আর twice pi L টা উপরে তুলে দিয়েছি। তাহলে এখান থেকে আমি Q by L বের করি, কারণ L এর ভ্যালুটা দেওয়া নেই, তাই আমি Q by L বের করি, because each case L will be same for each, length of the cylinder will be same. তাহলে from this we find out first Q by L. Again Q by L means twice pi for this cylinder. So এই ক্ষেত্রে কি হবে, Q equals to T1 minus T2 divided by twice pi into K, ln R2 by R1 divided by twice pi K into L. তাহলে সেক্ষেত্রে আমি কি পাচ্ছি, এক্ষেত্রে ln r2 by r1 টুয়াইস পাইটা উপরে আছে, তাহলে এলটা এদিকে চলে এসেছে, তাহলে টুয়াইস, মানে আমি ইকুয়েশনটা কি পাচ্ছি দেখো, কিউ ইকুয়ালস টু জানি যে আমি জাস্ট আউটার টেম্পারেচার T0 লিখছি, আমি যেটা ফর্মুলাটা হচ্ছে Ti equal divided by ln R2 means outer diameter by inner diameter divided by twice pi k into l হলো। এবার দেখো এখান থেকে যদি q বাই l টা যদি উপরে চলে যায় তাহলে twice pi k l into t0 minus t1, এবারে l টা যদি আমি q বাই l করি তাহলে কি হবে twice pi k into t0 minus t1 হলো। এখানে এই ক্ষেত্রে আমার কি আছে, এটা সিলিন্ডার, for this is the cylinder, তাহলে here inside temperature T1, this intermediate temperature T2 and outside temperature T3. So for this purpose, for this surface, so inner diameter will be this diameter and outer diameter will be this diameter. Clear? So for this we can find out Q equals to T twice pi k into L into T1 minus T. So this is ln R2 by R1 into K. So from this we find out what will be the value of T. Clear? আর কোনো ডাউট আছে তো বলো? If you have any doubt, you can ask me. Okay? Any doubt?
No, sir.
Okay. We go to the next problem.
No, sir.
Okay. The hot air at temperature 65 degrees centigrade is flowing through a steel pipe of 120 millimeter diameter. The pipe is covered with two layers of different insulating material of thickness 60 millimeter, and their corresponding thermal
हेलो
conduction.
सर, वो वाला प्रीवियस सम का थोड़ा सा एक बार भेज दीजिएगा सर।
बोलो
वो
क्या प्रॉब्लम है?
हम अच्छा से नहीं देख पाए थे सर। वो सर प्रीवियस सम वाला जो लास्ट का था ना, वो फॉर्मूला क्यू बाई एल करके, वो वाला पूरा जो था सॉल्यूशन, वो यार
अच्छा देखो,
स्क्रीन
देखो
पे
हम
लेते तो
क्यू क्या आ रहा है? Q equals to we know this is temperature difference about T2 T1 minus T2. So this is the cylinder inner diameter and outer diameter. Here inner surface temperature T1, if this surface temperature T1 and this surface temperature T2. So here T1 minus T2 divided by resistance will be for cylindrical surface, this is ln, outer diameter R2, inner diameter R1 divided by twice pi k into L. Okay. Now basically twice pi k L this will be the, if we write another way, this is twice pi k into L into temperature difference T1 minus T2 divided by ln R2 by R1. Okay. Here if we write Q by L, so Q by L equals to twice pi k into T1 minus T2 by ln R2 by R1. Now for this expression you see here this is the cylinder, this is another layer insulation, this is another layer insulation. This is another layer of insulation. Here you have to find the intermediate temperature. So we only consider any one, this one or this part or this part. Any part you can choose, because Q will be for same for all the material. Okay, so we know Q equals to first for this case Q equals to twice pi k into L, L term is by any, so this is Q by L, so twice pi into k, T1 minus T2 by ln R2 by R1 এই পার্টটা নি, so this is twice by T তখন হবে T2 minus T3 divided by ln R3 by R2 by kb. Clear? So you can choose any one and find out the what will be the intermediate temperature. Clear? Basically you remember one thing, I will show you one another thing.
हेलो सर।
अच्छा देखो यहाँ पर क्या आ रहा है, देखो Q इक्वल्स टू क्या होगा, देखो ईच टर्म में तुम्हारा ये तो स्फेरिकल है, ईच टर्म में तुम्हारा Q सेम होगा, मतलब देखो K twice pi L T1 minus T2 by ln R2 equals to KB twice pi L T2 by T3 by ln R3 by R2. Okay, now and this is Q equals to another one K T1 minus T2 by whole total summation of resistance. We already proved this for series. So we apply this principle and find out the intermediate temperature and total. Okay, কি বলছিলে বলো?
हेलो
হ্যাঁ বলো।
सर, वो इनर डायमीटर ऑफ द पाइप का कंसीडर नहीं करेंगे?
L दिया ही नहीं है ना, तो Q by L कंसीडर कर रहे हैं। L तो दिया नहीं है प्रॉब्लम में, देखो L कहाँ पर दिया है, ये जो प्रॉब्लम है कहाँ पर L दिया है, सिलिंड्रिकल।
यस, तो आउटर डायमीटर कोई मतलब आउटर डायमीटर ही मेरा R1 हो जाएगा।
हमारा सिलिंडर देखो देखो एक पाइप का क्या होता है, थोड़ा थिकनेस रहता है, स्मॉल थिकनेस रहता है, ओके वेरी स्मॉल थिकनेस रहता है पाइप। उसके बाद तुम्हारा इस टाइप का लेंथ होता है पाइप, ओके। तो यहाँ पर इसके ऊपर मैं इंसुलेशन दे रहा हूँ, इसके ऊपर है, तो क्या होगा, हम ओनली कंसीडर इन दिस प्रॉब्लम कंसीडर द आउटर डायमीटर ऑफ द पाइप, नॉट इनर डायमीटर। क्लियर?
ओके सर।
So next problem देखो, hot air at temperature 65 degrees flowing through a steel pipe of 120 millimeter diameter. The pipe is covered with two layers of different insulating material of thickness 60 millimeter and 40 millimeter, and their corresponding thermal conductivity at 0.24 and 0.4 watt per meter degree centigrade. The inside and outside heat transfer coefficient are 60 watt per meter degree centigrade and 12 watt per meter degree centigrade respectively. The atmospheric is 20 degree centigrade. Find the rate of heat loss from 60 millimeter length of pipe. Here length is given. Here length is given 60 millimeter, 60 meter. So any problem in your exam basically given this type of problem. First you draw the schematic diagram. So here you see this is 60 a steel pipe with 120 millimeter. So this is suppose 120 millimeter diameter pipe. Here the hot air will be the flow, 65 degree temperature. Okay. The pipe is covered with two layers of different insulating material, thickness 60 and 40 millimeter, and their corresponding value. So this is 60 millimeter insulation applied on this, and above another 40 millimeter thickness will be applied here. Here T1 temperature, here H1. T1 is given 65 degree, H1 is given 60 watt per meter degree centigrade. Okay, this is the A and this is the B. Okay, Ka given 0.24 and Kb is given 0.1. Okay, and outside temperature here air flow. Okay, another cold air will be the flow atmospheric air. So this temperature will be T2 and heat transfer coefficient will be H2 and T2 given 20 degrees centigrade. So T1 will be 65 degrees centigrade, it will be 20 degrees centigrade. So if we draw this, the thermal circuit. So first will be convective heat transfer rate. So আচ্ছা এটা T1, এটা হচ্ছে T2 and temperature T3, এটা T4 করে দাও। So first T1 to T2. So this is T1 to T2. This is the convective heat transfer rate. We know convective heat transfer rate for what is the resistance? What will be the resistance for convective heat transfer rate? For convective heat transfer rate, what will be the resistance? First tell me. Anyone tell?
So for cylinder,
Any surface. Any surface, what will be the resistance for convective heat transfer?
सर 4 सिलेंडर के लिए तो सर तो ln इज इक्वल टू r2 ln r2 by r1 डिवाइडेड बाय
This is the conduction.
2 pi
Conduction
kl.
में difference होगा plane wall, cylinder and sphere. But convective heat transfer always remains same for each surface. This is 1 by 8
1 by ha into 2 pi rl.
number क्या होगा 1 by
1 by ha.
h into contact surface area. So 1 by h.
Yes sir.
So here h will be h1.
Hmm.
And if we consider this radius will be r1. So this is the r1. So h1 into for this cylinder, what is the contact surface area? Twice pi r1 into length of the cylinder. So this is the resistance. Then T1 to T2. Sorry, T2 to T3. This is the conduction. So this will become such ln. Suppose this radius will be r2. So ln r2 by r1 divided by twice pi kl. K A hobe because it is a surface into L. Similarly, T2 to T3. T1 to T2, T2 to T3. আচ্ছা এটা ভুল হয়েছে এখানে আরেকটা সারফেস টেম্পারেচার থাকবে T4. এখানে T1 is the fluid temperature, T2 is the this surface temperature, T3 will be this surface temperature, and T4 will be there. This is considered this is T5. Okay. This is right T5. Okay, so T3 to T4. This is also same. তখন কি হবে এটা R2. So this is R3. This is R3. So ln. So this will be the ln R3 by R2 divided by ln R3 by R2 divided by twice by KL. Twice by KB into L. Small করে লিখলাম। Okay. Then T4 to T5 again convective heat transfer. So this will be again 1 by H. So 1 by H2 into twice pi KB into L. Sorry, twice pi R3 into L because this is the contact surface area R3 into L. Clear? So this is the you get the resistance. Then find out the summation of resistance. So if you know T1 and T5, so from this you find out the Q. Yeah. And if you know the find out the Q, so each tab. So suppose here Q equals to for this surface Q equals for T1 to T2 Q equals to T1 minus T2 divided by this resistance. Similarly T2 to T3 Q equals to T2 minus
T4 क्या है सर?
हैं?
T4
देखो T1 is the fluid temperature inside. T2 is the this surface temperature. This is the T2. This is the T3 and this is the T4 outer side, and T5 is the outside atmospheric air temperature. Clear? So T1 to T2 will be the convective heat transfer. T2 this point to this point will be conduction. Basically, 1 minute. This will be the T2. And T3 will be this one. Okay. So T2 to T3 is a conduction. So this is the your resistance. So Q equals to T2 minus T3 divided by ln R2 by R1 divided by twice pi K into L. And T3 to T4 again conduction. So this is ln R3 by R4. Sorry, R3 by R2 divided by twice pi K into L. And again T4 to T5 again convective heat transfer. So this is 1 by H2 into contact surface area. So outer radius will be R3. So contact surface area will be twice by R3 into L. So you find out the total summation of R, and for Q will be each time you know for this surface Q equals to T1 minus T2 by this resistance. For this Q equals to T2 minus T3 by this resistance, and for this T3 minus T4 by this resistance, and for this T4 minus T5 by this resistance. And equals to Q equals to T1 minus T4 divided by summation of resistance. Already we know this. Now from this you find out the Q and also intermediate temperature, means T2, T3, T4. Clear? All of you clear the problem?
Yes, sir.
Yes, sir.
হ্যাঁ স্যার বোঝা গেছে।
Yes, sir.
So now this is the drawing. দেখো here এখানে T1 জায়গায় THF লিখেছে TCF করেছে। ওকে, আর মাঝখানে T1 T2 T3 নিয়েছে। Okay, so here R1 R2 R3 K all given. So from this we find out, first we find out the typical, only the problem rate of heat loss find out. So you can find out that way. If we intermediate temperature, then individually you have to find out. So this is the 1 by HF. আমি যদি রিঅ্যারেঞ্জ করি তাহলে কি হবে, এই জায়গায় একটা আসবে twice pi L each term, totally go the lower part time, and this twice pi L each term. So if we write this, so কি আসবে T HF minus TCF divided by কি আসবে 1, এখানে একটা twice pi L, এখানে twice pi into L গুণ হয়ে যাবে, এদিকে একটা twice pi L এর মাল্টিপ্লিকেশন, here also twice pi L into multiplication, and here also twice pi into L, আমি আর করলাম না। So this is the resistance, convective resistance T1 to T2. This is T2 to minus T3 by this resistance T3 minus T4. এখানে কি আসবে, এটা হচ্ছে যদি আমি R1 ধরি, এটা R2, এটা R3, this is R4. Okay, so for this Q equals to, for if you find out the, suppose in this problem if we find out the intermediate temperature T1, তাহলে কি হবে, for this TCF cold hot springs HF minus T1 by resistance 1. তাহলে this is your resistance number 1, এখানে এই টার্মটা থাকবে না। So this is the resistance number 1. So you calculate all the resistance. So from this you calculate T1. Similarly, if you know T1, similar for this case, Q equals to কি হবে T1 minus T2 divided by R2. So you know the R2 equals to ln R2 by R1 divided by Ka into twice pi L. Okay, so from this you calculate T2. Next you find out the T3. In this way you can find out all the intermediate temperature. Clear? So for this composite material problem, first find out the initial temperature, first find out the summation of resistance. Each resistance you find out, then find out the summation of resistance. Then you find out Q equals to THM minus T by summation resistance. So from this you get the Q. Okay, so if you know the Q, if you find, then you find out the intermediate temperature. Means each part you can find out Q equals to suppose T1 THM minus T1 divided by R1, then T1 minus T2 divided by summation of R2, then T2 minus T3 by R3. In this way you can find out all intermediate temperature. Clear? কোনো problem এ তোমাকে find out the intermediate temperature also. So here only the heat loss, you do not require this, but if your problem find the intermediate temperature similar to previous one, you can find out all individual resistance. Clear?
Yes, sir.
So now we go to the one simple problem of spherical. Determine the rate of heat flow through a spherical boiler wall which is 2 meter in diameter and 2 centimeter thick steel. The outside surface of boiler wall is covered with a asbestos 5 millimeter thick. The temperature of outer surface and that of the fluid inside are 50 degrees centigrade and 300 degrees centigrade respectively. Take inner film resistance is 0.0023 kilo per Kelvin per watt. Inner film resistance means basically we know for convective heat transfer what the resistance 1 by H. Okay, so this is the resistance for convective heat transfer. So this is for inner surface, this is called inner film resistance, and for outer this is called outer film resistance. Clear? Here A1 by H is given. This is 0.0023 K by W. Clear? Now if we draw the drawing, so this is the drawing. You see in the problem outside there will be no atmospheric flow or any fluid flow is not given. Okay, only inside the fluid flow, and here the pipe thickness is given, thickness, and the steel pipe K is given, and on the pipe above insulation will be applied. Okay, so here Ti temperature given 300 degrees centigrade and outside temperature T3. So this is T1, this is T2 and T3. Okay, so you have to find out the Q. So for Q, what we'll do, this is the spherical surface. So for spherical surface, we know this is the resistance will be Q equals to, for conduction, we can know this is T1 temperature difference minus T2 any temperature. This is 4 by R1 R2. আমি ওটা লিখে বলছি দাও। So for this, what we'll do, first we find out R1. This is 2 meter diameter is given and thickness is given 2 millimeter, 2 centimeter. The one thickness will be given 2 centimeter. So from this we calculate the R2. So and similarly insulation thickness will be given. This is 5 millimeter thick. So from this we can calculate R1, R2 and R3. And Kb is given. K is the for steel and Kb is the insulation. Now we know film resistance is given. So we know Q equals to H1 into A1 into Ti minus T1 because heat flow from the fluid to the steel. So this is the convectivity transfer. So this 1 by Hi into A1 is called the inner film resistance. Okay. So we know Q equals to, here if we write the if we try to draw the circuit, so first will be what will be? First will be this Ti to T1 temperature, Ti to T1, and what will be the resistance? 1 by Hi into inner area. Inner area will be 4 pi K R1 square. 4 pi R1 square. 4 pi R1 square. Okay. Then T1 to T2. Then T1 to T2, what will happen? This is the conduction resistance in the spherical surface. Okay. So for spherical surface, what will be the resistance? Tell me. So for spherical surface, what will be the resistance? This will be the this is the radius R2. So this is R2 minus R1 divided by 4 pi K, এখানে A হবে 4 pi Ka into R1 R2. Okay, and T2 to T3. T2 to T3. So for this, what is the resistance again? R3 minus R2 divided by 4 pi Kb into R3 R2. So this is your resistance, each resistance. So total, first find out total resistance. So this is R1, this is R2, this is R3. Then Q equals to, you can write Ti minus T3 divided by summation of R. And same way you can find out the intermediate temperature also. So this is Q equals to, for this, if we write this is R1, this is R2, and this is R3. So Q equals to, the first one will be Ti minus T1 divided of R1. Same way equals to T1 minus T2, because this is steady state, so each part of T will be remain same. T1 minus T2 by R2 equals to T2 minus T3 divided by R3 equals to Ti minus T3 divided by summation. So anyone first you apply this expression, find out the Q. Then any one three formula you see, you can find out 1, 2, and 3. 3 is known to 1 and 2 intermediate temperature. So this is the problem. Okay, all of you understand? So when you do the
Yes, sir.
problem, any doubt?
No, sir.
So find you any problem for heat transfer, basic important part is that first you try to find out the schematic diagram of the figure, then try to thermal circuit like electrical circuit, this circuit try to draw, and from this find out what is the total resistance. Okay, then write down this equation, and you have to find out requirement. If you find out the heat loss, then you can apply any one equation. If you find out the intermediate temperature, then any application you can find out. Okay. So here only the heat loss find out. So this is the Q. This is the summation of total resistance. Okay, and we can find out the heat loss. Then you can apply any one equation. And here remember one thing. Here inner Q resistance given is 1 by HIAI is given. Means this resistance is given already in the problem 0.0023. This is called inner Q resistance. If it is H0 and H0 and H0, this is the outer Q resistance, means outer surface area. Here. So this is about the calculation. কার কোনো ডাউট থাকলে বলো। And I will send the note today. And up to this is your first internal syllabus. And all of you take the attendance. কারো যদি কোনো ডাউট থাকে বলো।
অ্যাটেন্ডেন্স দেওয়া হয়ে গেছে।
হ্যাঁ আচ্ছা ঠিক আছে, কিন্তু যদি কারো কোনো ডাউট ঠিক আছে ওকে, আর কারো কোনো যদি ডাউট থাকে তো বলো।
নো স্যার।
আচ্ছা তোমরা কারা কারা এনপিটিএল আছে বলো তো, তারা একটু আনমিউট। হ্যাঁ সবাই সাবমিট করে দিচ্ছে অ্যাসাইনমেন্ট, বা কোনো প্রবলেম হচ্ছে
স্যার কালকে রাতে।
Yes, sir.
প্রবলেম হচ্ছে, যদি প্রবলেম হয় আমার সঙ্গে কন্ট্যাক্ট করো যে স্যার এই জায়গায় প্রবলেম হচ্ছে, ঠিক আছে?
Okay, sir.
যদি প্রবলেম হচ্ছে লাস্ট ডেট অনুযায়ী বসে থাকলে চলবে না, কারণ অ্যাসাইনমেন্ট আগেই সাবমিট করে দিতে হবে। অনেকে করে দিচ্ছে আগে, যদি যারা করছো না তাদের কথা বলছি, কারণ কি তুমি তোমাদের এটা 40% মার্কস হচ্ছে করে 30। ওকে, তো যদি তুমি অ্যাসাইনমেন্ট যতটা মার্কস করতে পারবে ততটা তোমার বেটার, কারণ ওই আমাদের
মিনিমাম মার্কস কত চাই স্যার
40%?
অ্যাসাইনমেন্টে পাস করার জন্য?
অ্যাসাইনমেন্টে কোনো পাস করা নাই, টোটাল 40% মার্কস দিবে, তাহলে 25% মার্কস দিবে অ্যাসাইনমেন্ট থেকে, আর 75% এমপিটি। তাহলে এদিকে যতটা পার্সেন্টেজ বেশি রাখতে পারবে তত বেটার হবে না? তাই না, অ্যাসাইনমেন্টটা সবাই সমান করবে, কি হবে এটা অ্যাসাইনমেন্টের মার্কসটা কমে যাবে, তারপরে কি হবে 25% মার্কস দিয়ে অ্যাসাইনমেন্টের মার্কসটা কম হয়ে যাবে তোমার। ঠিক আছে, যদি কোনো প্রবলেম হয় বুঝতে বা কোনো প্রবলেমে যেদিনে ভিডিওগুলো, যেমন ধরো থার্ড উইকের ভিডিও অলরেডি চলে এসেছে, তোমরা থার্ড উইকের ভিডিওগুলো দেখো, যদি কোনো প্রবলেম হয় আমার সঙ্গে কন্ট্যাক্ট করো আর ডিসকাশন করো। ওকে, ঠিক আছে, less than 1 minute so we can end the meeting. And I will share the note.
Okay, sir.